Hello everyone, welcome to webinar on RC building using MIDAS nGen. I'm Nivedita Khole. I'm a technical support engineer of MIDAS. I hope you all are able to hear me. If not, please let me know. You can write at the questions box to let me know if you're not able to hear me. Or you can also click on raise hand to let me know if you are able to hear me. All right, great. Thank you very much for your replies. I will go ahead now with the presentation. Okay, so let's start with the contents. So today's webinar is going to focus on RC buildings, and we will start with a small introduction on MIDAS as a company. Then we will look at the introduction for MIDAS nGen. We'll look at its application areas, like where you can use it. And we will have a strengths demonstration, and we will talk about how you can learn how to use MIDAS nGen software solution. And lastly, we will have a conclusive slide, and then we'll take up your questions. So in case you have good questions, you can just write down at the questions box. You can write it during the session or after the session. We will definitely get back to you at the end of the session, or maybe through emails. Alright, so let's begin now. We will start with the company introduction. Well, MIDAS as a company was established in the year 1989, and since then the softwares sold by MIDAS have been distributed in more than 120 countries. There are more than 540 employees, more than 18,000 number of clients, and more than 40,000 number of users worldwide. MIDAS originated in South Korea. So that's where our headquarters is. And all over the world, there are 9 branches. Excuse me. And we have one in China, one in USA, India, Japan, UK, Russia, Singapore, Philippines, and the UAE. MIDAS has 2 main business areas. It has engineering consultancy for bridges, buildings, geotechnical and mechanical analysis. And depending on the practical requirements of these consultancies, these softwares have been developed again in the field of bridges, structures, geotechnical and mechanical. So let me tell you about all the softwares that are offered by MIDAS. Well, MIDAS is a biggest CAE software developer, as it has got softwares, all the softwares integrated with each other, and they are in the fields of bridges, structures, geotechnical and mechanical. So I'll talk about these 4 family programs. Under the bridges, we have got MIDAS Civil, which we have actually had a session yesterday, webinar session on MIDAS Civil. We can perform the analysis and design of simple RC slab bridge, box culvert bridge. We can also perform the analysis and design for PSC composite bridge, steel composite bridges. We can have various construction stages included in it. We can also perform the analysis for the cable stayed and suspension bridges, as well as the advanced bridges like extrudos bridges. So that's MIDAS Civil, very popular all over the world. Then we have got MIDAS FEA. MIDAS FEA is an advanced nonlinear and detailed analysis system. So you can actually perform total strain crack analysis or contact analysis, impact analysis, all these analysis in MIDAS FEA software solution. Then further, you can look at the structures family programs now. Here we have MIDAS Gen, MIDAS nGen, MIDAS D-Shop, MIDAS Set and Design Plus. Today we are going to be looking at the structural program, which is MIDAS nGen, and we will see how it can perform the analysis and design And further, we can take this design result into MIDAS drawing, which can help us to get the drawings, structural drawings, elevational drawings, even longitudinal rebar reinforcement drawings, and bar bending schedules. You can also get this bill of materials, and then further there is MIDAS Set and Design Plus that can give you the design and drawings for structural components like staircases or isolated footings, pile caps or bolt connections, and so on. So that's about our structural solution. Then further we have geotechnical solutions as well. We have 3D geotechnical solution, that is GTS NX, which is based on finite element analysis. And then further there is SoilWorks, which is our 2D finite element as well as analytical based geotechnical solution. Under the mechanical field, there is MIDAS NFX and MIDAS FX Plus. Now let us look ahead to some of our major users worldwide. These are into our bridges or structures or geotechnical fields. So they are using one of our softwares, at least one of our softwares, if not all. Let's look at the local users in Africa. So these are our power users in Africa. They are the leading companies highly using MIDAS software solutions in the field of structures, in the field of geotechnical and bridges. So you can see how they are all into private, they are into government, educational, and so on. This is another list of our power users. I hope your companies also would soon be on this list. So let's go ahead now and see how MIDAS nGen could be beneficial for you and your work. So MIDAS nGen is the next generation solution for building analysis and design. It includes the analysis tool, the design tool, and the drafting tool. I would say MIDAS nGen is a one-stop solution that can start from drawings and end with structural drawings. So from drawing to drawing, you can get everything integrated under one solution. You can do the modeling through the architectural drawings. You can get the analysis performed, get the design checked or done. You can get the reports generated, the quantity takeoffs, and finally the structural drawings. So it's an all-in-one design system having integrated solutions, and there is automation to make your work fast and optimization to enhance the quality, and also there is high quality design output result that you will get in a Word file format. So that's about MIDAS nGen. Now let us look into its application areas. With its optimized and automated features from modeling to report generation, you can get a multidisciplinary and fully integrated solution for structural design. So what can you do with MIDAS nGen? Well, these are some applications. You can have apartment buildings, you can have commercial buildings, like building having concrete frame totally from the ground floor, and you can have a steel roof at the top. It's a car park and building, actually, that's the example. You can have a multi-towered structure, not just frame analysis, but you can also do shell analysis and design in the software. So that these are some of the applications. Now let's look into the strengths of MIDAS nGen. Alright, so firstly, we'll talk about the integration. Integration basically you will have all the features integrated into one solution. Features including modeling, which is easy and fast because we can use CAD softwares to get the modeling done, and it's a CAD based system itself. So it's easy to use the modeling tools in MIDAS nGen. You can have loadings automatically generated for slabs and lateral loads as well, like wind loads and seismic loads. Then we have analysis, which can perform buckling and P-delta analysis. You can perform optimal design and get an output generated in the form of Word files and drawing files. So it's a one-stop solution. Let's look into the automation. To make your work easy and fast, there are several automated tools in MIDAS nGen. Let's firstly look at the CAD Tracing tool. So you import your architectural drawing and then you trace all the columns. You can trace the walls as well. And further you can go ahead trace the beams. So by simply selecting the center lines of the beams, which were actually created as grid lines in the architectural drawings, that's also possible. And this is like you can create manually as well wherever you want the beams. Then further slabs also can be created by simply selecting all the beams, and wherever there are openings you can just delete those areas. So that's about the CAD tracing automation. There are several options as well available for the CAD based modeling, like editing tools. Let's look at those editing tools and modeling tools. So this is how you can copy at several times. You can stretch, you can extend, you can trim, create the slab easily, and to make the opening, just create the opening in this way. So as you can see here, it was very quick to model and to perform the editing of the model. It's like CAD based tool itself. If you remember, all the trim and extend options are available in CAD, so it's the same thing. Next, when you have got complicated models, you can still use lofting functions. You can use sweeping functions. Then further you can mesh. This is automatic mesh that is generated by the program. You can further reduce the mesh size as required to get the stress checks more in detail. So that's about automated CAD based modeling tool. Then coming to the wind loads and seismic loads, well, you have European standard which can be selected to perform automatic wind load calculation of buildings, of enclosed structures. You can specify the windward, leeward directions, the sidewall directions, roof information, windward roof and leeward roof information. You can apply the lateral loads like wind loads on open structures as well. And you can convert you can get the wind loads from the reactions. So these are some of the automated application for the wind loads. Similarly, when it comes to seismic loads, we have again European standard that can be used for automatic calculations. So the program can not only do the static seismic load, but also the response spectrum loading can be applied. Then irregular shaped type of geometries can be easily modeled using variety of CAD based features in the software. Finally, we will come to the high quality output that the program is able to create. But before we get to this high quality outputs, I would like to go to MIDAS nGen and show the demonstration until the output is being generated. Alright, so that would be the start of our demonstration. Let me open up MIDAS nGen software. Okay, I hope you all are able to see the software. Well, this is MIDAS nGen user interface, which we will start by opening up a new file. Alright, so new file is generated, and now we will go ahead to the user interface. So let me introduce you to the user interface of the software. We have ribbon menu at the top, and MIDAS always takes care that the workflow is very much easy. So it has got different tabs arranged as per the work procedure from left to right. So as you can see here, there is structure tab, define tab, member, body tab. All these can be used for the modeling purpose. Then you go towards the right side to apply the load, apply the boundary conditions, to perform the analysis, the design, and check the results. Then get the reports and the drawings generated finally. So from left to right, you finish with your entire model. Further, we have got tree menus available. There is modeling tree menu that gives you information about what all elements have been applied, members, and the properties, and so on. Then we have analysis tree menu that gives information about the boundary conditions and the loading conditions and the analysis cases. We have a design tree menu that gives information about any reinforcements that we have applied to our members, and also the design groups. Then further, display, so you can actually change the color of your background by simply double-clicking on it. We have a table tree menu to give us the input information in the form of tables and also the output information in the form of tables. Then further, we have a properties menu over here that gives information about any selected member, what property we have assigned to it, what type of element it is following. So all that information we can get from this properties menu. This is our work interface, workspace, and it has again three modes. We have a 3D mode for working on general structures easily. Also, you can work on building structures very easily using 3D mode. We have a plane mode in case we want to do some modifications or create a geometry at a particular plane. There is a story mode to switch to different stories for a building structure. Then we have got viewing tools over here. You can easily go to any view by using this box cube over here. And also, if you just click on the middle button of your mouse anywhere, you will be able to see the common views and view angles. So front, left, isometric. So you can, wherever your mouse cursor is, you can just change the view. It actually is very easy rather than moving the mouse to a particular shortcut tool for viewing the model. So that's about the user interface of the software. The software is based on finite element analysis. Let me change the unit system to kilonewton meter right now. This can be changed at any point of time in the pre-processing or the post-processing mode. Now let us begin with the modeling. In the modeling, based on your project, you can decide the method of modeling. There are several methods. Let me begin with the importing type. When you want to import files from, let's say, Revit or Tekla, you can just use the MIDAS-gen text file. Then we have import from STAD, and we have import from Parasolid as well as DWG or DXF files. So CAD files can also be imported easily in the software, and you need not worry about modeling anymore. So that's about importing. Then second method is using the architectural drawings. So in the presentation we saw how tracing files can be imported and traced. If you want, I would like to just quickly show you about how this tracing actually works. So here we are. Let me go to materials. We have tutorials on these so that you can practice it by yourself. Alright, so I've got my tracing files, then I create my story information. I add a story. Then I put on each story the architectural drawing. It's a DWG file, so I'm putting it at each level and I click on OK. Then I go to my story mode over here and I go to my members and then I trace my columns first. So I select the appropriate material property, just drag to select all the columns. The columns are getting detected. We can see the preview and simply click on apply. So as you can see over here now, by just doing this much we have created so many numbers of columns, and they could be of different shapes. Not necessarily they are of single shape. They could be rectangular, they could be even circular. Similarly, we can trace the walls. So I select the wall and just drag to select the lines and click on OK. So there we go. We have got the walls with us. Similarly, we can go to the roof level and we can select the center lines for generating the beams. So I'll select the default section properties that are available in MIDAS nGen software. So I simply make a box to select all these lines and click on apply. So this is how my beams are also generated. And finally I can go ahead to create the slabs again by selecting all my periphery beams or periphery walls. So I simply click on apply and there we go. We have got our slabs generated. So wherever there isn't any requirement of the slab, I can just select and delete. So this is how you can trace the entire architectural drawing and get the model generated. I'm going to open up another file and show the next method of modeling. As you can see over here, in single MIDAS nGen window, you can open multiple project files. The next method of modeling is by using 3D grid lines. So you can actually define grid lines from here in the 3D format. So let me provide information over here. Let's say there are 6 at 4 meters, like 6 spacings at 4 meters each. Then we have got, like, let's say irregular spacings in the y direction, so 3 at 5 meters. And then there are 2 spacings at 2.5 meters. And then I have got several levels with different floor-to-floor heights. So I provide that information, like there are 2 numbers at 4 meters, then 2 numbers again at 2 numbers at 3.5 meters and 2 numbers at 2.8 meters. And that's all. I can simply click or press even enter from my keyboard and get the 3D grid line generated, ready to use and ready for me to create elements or members. So what I do is I use my 3D grid lines to create members. I'll start with the beam. So we have got some predefined section properties, but if you want to define the section properties by yourselves, then you can go in the next tab, that is to define the tab. Define the material property from here. There are several standards available with us. British standard is there, BS and BS04, latest one, EN, EN05, and so on. So there are several standards available, and for each standard there is a complete database of grades of concrete and steel. So that's about our options available for the material definition. And Then further there is definition for 1D section. This is also very interesting. This is like you can have some predefined shapes. Several predefined shapes are there as per the code. There is again a huge database for the shapes. So BS standard is there for the steel. When it comes to RC, you might have irregular shapes. So you can actually sketch your irregular shape over here. So let's say I draw lines to create my shape. I'll start with the 0 location and provide, let's say, 300 as the dimension. This is by pressing enter. And then further I just make an irregular shape over here, just for an example. I right click, then I can simply select after making the entire section, and then I can select this defined section and my section is defined. It's that easy. And then I can actually give it a material definition, call it as irregular, and click on apply. So now if I want to use it, I'll go to the convert into member, and let's look at this section now. This is an irregular section. Let's say I select this line over here and I click on apply. As you can see, this is the irregular shape geometry for our section property, generated automatically. I mean, very easy. I wouldn't say automatic, but easily as compared to any other software solution. So that's what our section definition is. And we will go ahead now. We can keep this define section definition option open, or we can close it. And we will use the default section properties that are already there in the software. Alright, so let's convert our grid lines into members now. We will start with the beam and use a default section that is 400 by 600. We can go to the front view and we can select our horizontal grid lines. Those will be automatically selected, horizontal ones. Then we will go for the column. Yeah, let us select the default section of 500 by 500. Make a box around the entire grid line. Click on apply. And as you can see, this is not just because I'm in front view, I'm not just selecting whatever I see. I'm selecting everything that is there with me. It actually makes it easy for us to do the modeling in this way. So by two definitions, by 2 clicks, I was able to create the beams as well as the columns. And similarly, I can go ahead create my walls. I'll go to the top view. Now again, we have a good option over here in MIDAS nGen, and that is by clicking or by saying space bar, you can get back to the previous command, just like AutoCAD. So now you can go to the walls and then you can select the thickness for the wall and select the type of member it is, if it's going to behave like plate, if it is going to behave like a meshed one or a not meshed one, and a membrane type. So there are actually various types depending on the design and the analysis. So of course, when you start using the software, you can understand why and what is the benefit of having these different types of members. Okay, so I'm going to be like selecting these corners for creating my walls. I'll select this one as well. We will see the openings in the walls and I'll click on apply. Okay, so we have got our walls over here generated. You can see that. Now there are some members that I do not need. So what I'll do is I'll go in the top view and I'll delete those members. Now we can actually go to our member and filter out the types of members to be selected. So beam and column are selected so that my walls won't get selected over here while I'm selecting them and I have to delete them, right? So I'm selecting only the beams and columns over here using my filter, and after that I can just press delete from my keyboard. So that's it. We have selected and pressed delete and they are gone. So it's that easy, that's fast. Now further, let us create the slabs. So we will go to the member and we will go to the slab definition and we will simply select all the members. So beam members are being selected right now. We can see the preview. So that's the preview we can get. Then further we can select its thickness. I'm using 150 mm thickness. Again, there are types, like you can make it behave like a plate or a membrane. Now I do not want my slab to be generated in this portion as it's my lift well. So I press shift from my keyboard and I deselect this part. Automatically, as one member is not there, the slab is not going to get generated in this portion. So now it's released and let's click on apply. So this basically is going to generate our conventional type of slab, the one-way type distribution and the two-way type distribution. As default, it will generate the two-way type of distribution, and in case we want to do the modification, let us go to the basic filter and let's modify the direction of load distribution for these slabs. So right now all these slabs from top to bottom stories are selected, and here in the properties we get the information about the selected slabs. We can simply change this one-way direction to two-way to one-way direction, and in case we want to change the loading direction, that's also possible. It's, I think, right to keep it in this direction itself. So that's one part. Now further, to make our structure look exactly the way we want, let us delete some portion of it. So it's an irregular shape building, that's what I'm trying to make. This is the front view, and I'll go to the left view now and select some of the bays. Over there we do not have the beams and columns. Alright, so here we go. We have our structure ready with us. Okay, now let's look at some more modifications. For modifications, what we can do, let us say we want to create the openings for these walls. So I want to actually model the openings at this plane. What I'll do is I'll go to the plane mode, I'll select this plane, and that's what we have over here. Let me just view entities that are in the plane. Okay, so we can see only the the walls now, and now we will go to the body tab to create the shape of our opening. So again, over here it's that easy. We just simply select line and we sketch our opening. I'll press F8 to make it a straight line. Okay, let us look at this by not viewing our thickness. So as you can see over here, this is one line that is generated. I right click so that the definition is turned off. Now I'll select these and I'll copy them at the upper stories. So copy option is also there by using two points. So I can simply click on every point over here. I can also give it the information how many times it is supposed to be copied at certain distance. So when you have got so many number of stories, you can use the copy tool in that way. Anyway, so I have got my openings or periphery of openings over here. Now I go to the member and I go to the openings. I select all my periphery members and click on apply. There we go. We have got our openings generated. Let us go into 3D view now. That's our openings right over there. We have successfully generated the openings for the walls. Now we can also generate openings for the slabs. So let's say I want to make an opening on this level. So I go to that place and then I simply go to the body tab. Let's say I want to make a circular opening. I take a center and let's make this as a circle. Okay, and then I go to the member tab, go to the opening, simply select this periphery and click on apply, and the opening is generated. So it's that fast to create the openings anywhere. Alright, so that's about the modeling in the software. And yes, one more thing, in case you would like to give let's say a drop in the slab. So you can simply generate deep beams over here. Those will be the periphery beams. Let me delete these beams. Alright. So I'm deleting these beams right over here. Let me do the selection filter for easily selecting all the beams. Okay, so these beams are selected, and now I'll create my plate beams so that the location of my slab could be at any height of the plate or of the beam. So this is actually a very approximated feature in other programs, but you can actually make it accurate in the software of MIDAS nGen. Okay, so I've put a thickness of 300 and a depth of 0.6 itself, and now I'm going to simply finish creating these beams. So it's very easy. I'm just snapping onto the end points. That's it. Right click and we are done. Now let us move our slab. So I'll select this slab and move it in a vertical direction. So I'll give it a direction over here. Let's say I move it at minus 0.4. Okay, and I press enter. So as you can see over here, a drop slab is generated successfully, and after performing the analysis you will see that it is connected to the plate beams. The design of the plate beams will be generated as per the beam, as any other beam. So we are done with our modeling. Last thing that we need to do is to define the stories. So let's go to the structure and ask it to automatically generate the stories. So how? We can simply click on auto generation, select all our members and click on OK. The program automatically finds out the location and it will provide us the information accordingly. So there are some locations where the program has detected the story level, so we don't need it. We can simply delete that data. Okay, so that's about it. We can also select this. This is also not required, story data. Okay, so these are our floor heights. Again, we can modify the floor heights from here and those will be reflected directly in the model. We can modify the names as well of our stories. So let's say this becomes a 3F, this will be 4F, and this is also Excel compatible. Alright, so you can just copy paste your Excel sheet information over here. So story definition is provided. Let us clear our screen a little bit by undisplaying all the hotspots. So let's undisplay our grids, let us undisplay our references, and there are a lot of like two-way direction that we can see. Let's undisplay those as well. Okay, now it's very clear and we can now go ahead with the loading part. So we are done with the first 4 tabs. I would say the first 3 tabs because body can also be used to create the patches on which we can apply the loadings. We will see that. Okay, so we are done with the first 3 tabs for creating our structure. Now we will move ahead to the loading part. In the loading part, we can apply the sulfate by simply going to the sulfate over here and clicking on OK. Then we can apply point loads at any point, beam loads on our beams, then pressure loads on any plate element or plate member. Temperature loading or thermal analysis is available in the software. You can apply displacements, and then it comes about arbitrary loading. So let's say you have got a wall going through the slab, like across the slab, and for that you can go to the body tab and create a line. So let me go to one particular location, let's say the roof level. I'll go by story. So I'll go to the story, roof level. On this roof level, I will create a line. Let's say my wall is going through these slabs. So I create my line over here for the element load, and then let's say I have got some patch loading on this location. So I go to the face and I create an area. So I'll make it irregular. So it's an irregular shape on which the patch loading is applied. Okay, now I've created this information. Let's go back to the 3D loading, and we will go to the arbitrary load. We'll go to the line load, and we'll select the line on which my wall is being located. Let's change the unit system to kilonewton meter and provide, let's say, -10 kilonewton per meter as the load, and click on OK. So you can see over here there is a loading applied. Similarly, I can go for the patch loading on arbitrary pressure. So I select this area and I apply an arbitrary pressure of -1 kilonewton per meter square. That's my dead load. So this is how I can apply arbitrary line loads and patch loads. Now let's go ahead and apply some slab load. We also need, along with the dead loads, the live loads. So by default, the slab load type 1 is a dead load type of load set. Let us create another load set for the live loads. So that is done. Now let us apply the dead loads and live loads at once on the selected members. So let's say I have got a dead load or floor finish of -1 and live load of -2. I add it and close. Now I apply this information to all the selected slabs. So this is how easily I select and simply click on OK. In the loads tree menu, you can see under the static loads there is dead load and there is live load. And you can see that at once all these slab loads under the dead load and the live load have been applied. In other programs, you have to separately select the load cases or load sets and apply the dead loads on the same slab. Then again select the same slab again and apply the live loads. So it becomes a kind of a tedious procedure when there are so many types of loads that you need to apply on the same slab. So I suppose this would become actually a faster way of applying the loads when it comes to slab loads. We also have got floor loads in case you do not want to model the slabs. So that's for the later discussion. Let's move ahead now to the next part of lateral loading. We can apply the lateral loading on the structure, wind loads and seismic loads. So those are again, as I showed in the presentation, on enclosed area, open area, equipment type and building type. We have buildings, so we are going to be applying the wind load in both the directions at once. No need to create any load case and no need to create any load set. The program will automatically do it for us. All we need to do is define a design wind load. Now we have these codes available with us. There is American code and European code as well as British standard BS 6399. So as this session is going to be completely on Eurocode, we are using this code over here. The program automatically detects the height. You can provide the parameters as per the site condition and you can simply click on OK. So as you can see over here, there is a preview of the wind load that will be applied on the structure. You can also see the profile or the forces on each floor in this way. And then just click on OK. So as you can see, the wind load in X and Y direction both have got applied. And you can verify that from the loads tree menu. There is wind load over here in both the directions. Let's apply the seismic loads. It's a similar procedure. So once you know how to apply the wind loads, you can go ahead with the seismic loads as well. So here we have the options for positive or negative eccentricities. You can keep it none. And then the design seismic load definition. Here again we have the American as well as the UBC and the European standard. So you can select the appropriate standard and then come to the approximate period. This approximate period is as per the standard again, and you can see over here all the formula available. You can simply select the formula that is most suitable for your structure and simply click on calculate. The program will automatically calculate the approximate period. If you want, you can manually provide the period information over here as well. Let's click on OK. We are done with the design seismic load definitions. Now let's apply the seismic loads in both the direction at the same time. So I provide the scale factors to each direction. We can even look at the base shear before performing the analysis. The loads to masses will be automatically generated for our self weight. So let's click on OK. The external loads can also be converted into masses. So for that, we will go to the boundary tab, which is the next tab. So as you can see, we are following the workflow from left to right, and it makes the process actually very easy. So we're in the boundary condition. We go to the loads to mass and we apply our external loads masses. We convert our external loads into masses. So I'm considering 25% of the live loads, and I'll click on add. So 100% of dead loads, 25% of live loads in the X and Y direction. Just click on OK, and we are done applying the masses to the structure. So that's how we can do it. Then further, rigid diaphragms. So sometimes you apply the rigid diaphragm, sometimes you don't. It depends on how your structure is, depends on the codal provisions and which code you're referring to. So I would like to just simply show you how to do this. So there is a diaphragm. So in this case, you can simply select your slab or your floors and then click on OK. And automatically there will be the generation of floor diaphragms. It will automatically find out the center of mass and connect all by itself. So that's about the rigid diaphragm. That will be done using the diaphragm option. Now let's go ahead to the support conditions. Then support, let's apply fixed support to our building. Let's go to the front view and select the bottommost nodes, and we have got predefined support types, fixed and pinned. So I'm using the fixed type and click on OK. So we have got the fixed condition as well, and we are done with the boundary conditions. Now let's go ahead to the analysis part. And in the analysis part, we have got the load combination option. Load combinations can be automatically generated as per the standard. So you can select any standard from here. We have got design as per Eurocode, American as well as British standard. So if you are using British standards or American standards, you can still do the same procedure that I am showing over here. Okay, so we are using Eurocode, and now let us automatically generate the load combinations. So we have auto generate feature right over here. So it's going to create the fundamental, that is the strength load combinations and the serviceability load combinations for the accidental seismic characteristic. I think there would be frequent and quasi per minute as well. So I'll click on add over here. The load combinations will be generated. You can edit these load combinations as well, and you can add your own load combinations also. So that these are the different possibilities that you have in the software. Now let's go ahead to perform the analysis. One very interesting part about MIDAS nGen is that you can create several analysis cases in one model file. So you can actually include certain loads, you can include certain boundary conditions for your structure and perform the analysis at once. So as you can see here, there is a definition which can help you to include or exclude any definition. You can have several sets of your structure members, and you can select them. Can select several types of loads that you have applied. Then further you can include the P delta analysis. In case of steel structures, direct analysis is also applicable. And in case you have got non-linear springs applied for the foundation purpose, you have the option for non-linear parameters, wherein the iterative method will be used for performing the analysis. So these are the options available for the analysis. We'll create one analysis case that's shown over here in our analysis tree menu, and now we will go ahead to perform the analysis. So let us run the analysis. We will save this file. So let me save it in a folder. Alright, now it has asked us if we are allowing it to convert some of our membrane type of plate of our slabs into plate type of slabs. So plate type of slabs would be actually required where we have got irregular shaped slabs and we have got openings, or our slab is not having a periphery beam. So in such cases, the program is going to convert it automatically into plate type of member, which is good because it's accurate. Alright, so the analysis is now taking place, and we can see at the bottom of our page how the program is generating the analysis, and it's quite fast. The analysis is completed within seconds. You can see over here in our message window that within 1.626 seconds the entire building is analyzed. So it's that fast, and now let's look at the results. The results automatically open up in the tree menu right over here, and to view any result, all you have to do is simply double click on it. So this is the displacement, XYZ displacement. Let me undisplay the diaphragms and the masses so that it will be a clear view. Now display and display is very easy by simply checking and unchecking information. I'll undisplay the supports, and yeah, all the loadings are also undisplayed. So we have a clear view now, and let's undisplay our reference as well that was newly created, and we'll go back to our results tree menu. So here we go, we have got our deformed shape which can be checked on over here. That's our deformed shape that we can see, and that's one part. Alright, let's look at some more results. This is, the result is in meters. Let's make it in mm so that we can see the maximum value. It's 1.7, and this is for the static load that has been applied, the first load case. Okay, so that's one thing. Now let's look at some more results. Let's look at the reactions. So these are the reactions. We can display the values. We can look at the reactions, or we can look at results for any load combination as well. So you can just go over here to the load combination that you desire to see. So this is the fundamental max. We'll go on the undeformed shape, and we don't need to look at these body elements, so let us simply undisplay them. Alright, so here we go. We have got the values. Let's look at all the values. That's the value for our reactions in the Z direction. You can see the reactions by simply double clicking. Now if you want to look at the reactions in the form of tables, then you can simply go to the table and look at the analysis results, reactions table. You can select over here the load combination for which you want to look at the results of. So that's the fundamental, and you can select which of the reactions you want to look at. So that's like, you can make it very intuitive and check the reactions. You can also look at all at once. That's not a problem. Now this table that you see over here can be exported to Excel sheet as well. So that's about the table format of result and the display format of result. Let's also look at we can get the applied forces as well onto our nodes that are generated, and can look at the actual forces for the columns. So it's going to show us all. Let's look at the maximum one only. Alright, so basically this is the actual force in the column. Let's look at the shear forces as well. You can see the shear force in the beams. You can go to any story to look at a specific result. You can also go to a particular plane to look at the result. So planes are like supposed to be created, and then you can click on that plane view likewise, and you can look at the results at the top view from the plane right over here. Alright, so that's about the story view. Let's go to the isometric and let's look at some more results. Can get the bending moment as well. So this is the bending moment result for the static load case 1. You can go for the load combination as well. This is the result for the load combination. You can look at the information over here. Let me make it kilonewton meter for reasonable values. Alright, so that's about the beam forces. You can also get the forces in the walls. So that's actual forces in the walls that you can get, and the bending forces and shear forces as well. So that's about the wall forces. There are beam stresses and plate stresses also that we can get for our members. These are the analysis outputs we can get. One more interesting fact about the analysis output is the story checks. So there are several checks as per the standard that we need to go through. Let me start with the story drift check. So as you can see over here, the program has actually given us a remark for a particular load set. So let's select the lateral load set, let's say wind loads, and let's look at the results. So this is the information about the story at the center of mass, and you can also change the parameters over here. You can select the code from here. There is ASCE and there is IBC, KBC as well, but you can actually provide your own information over here. Like over here, story drift. So just the allowable ratio has to be modified. So you can specify the allowable ratio, and you can ask it to check for all the vertical elements or at the maximum drift limits. So once those are modified, you can see the results over here. Now another thing is about the graphs that can be generated. So let's look at that. We will be closing this. One thing is done about the remarks, and we will close this information. Okay, so graphs can be generated by using the on-curve diagrams. So those are can be done on the plate type of elements. So let me go to the 3D view now and initialize the view. So for on-curve diagram, you can actually click on 2 points to create the on-curve and click on OK. So that is one on-curve diagram that we have, and then we can simply double-click on any of the results. Let's say we want to see the forces in plates. So we can just double-click over here, and that's how we can get the information about this location. Alright, so that's about the plate cutting diagram. Let's initialize the structure now, and we'll move ahead to the design part. Okay, so we'll go to the reports. Before we go to the reports, we'll go to the design, and then we'll go ahead to the reports and drawings. So yeah, design. Let's perform the design, but before we perform the design, we are going to be creating groups. So for the groups, we have the option for automatic generation. We will simply click on OK, and the program will automatically generate the design groups. And there are several ways as well for creating the design groups. We have got level of details for creating each design group. So that can be basically selected, and then the definitions will be generated. So as I've chosen a third type of detailing limit for the group generation. It's taking so much time, but yeah, it's done. So we have got our groups generated, and now we will go ahead to perform the design. Now in case of design, you can actually choose which members are required to be designed. So similar to analysis cases, you can generate several design cases as well. Yeah, so design groups are done. Next, you can also apply your own reinforcement and check as per the standard if your reinforcement is okay or not good. Let's apply a design case right now. So design case is there with all the design groups, and the load combinations are there to select. Also the results from analysis for design case 1 is there, and we'll click on OK, and we'll go ahead to run the design. Now if you have applied your reinforcements, then you don't need to do the auto rebar arrangement, and if not, you can just ask the program to perform the design with the minimum and maximum diameter inputs. So by using these inputs, the program is going to generate the arrangement for the reinforcement. So we have got all types of options available for the design. As you can see, there is beam, column, brace, plate, wall, slab, flat slab, and foundation design. When it comes to staircase, yes, you can draw the staircase, you can model the staircase in this software using the plate elements and perform the design for plate elements. Or you can design it as a slab also. So let's click on OK, and now we'll go ahead to perform the design. So design is being performed right now. Let us look at the design results after this. The design results can be viewed very easily over here by simply looking at the main status. There is a total status over here that will help us to know which of the members are passing and which of the members are failing by just looking at the color and the legend. So as you can see, major quantity of member are passing, that's blue in color. That is okay. Then there are some members which are critical, and there are some members which are failing. They are not good, they are failing. Okay, so we can actually get to know about all this information by simply double clicking on this status. We can look furthermore if they are failing in strength or if they are failing as per the serviceability. So as per serviceability, only these plate beams are failing. Probably their thickness was supposed to be a little bit more. The width should be more. We can do the modification, rerun the analysis and design. Then further, if you want to know more where exactly it is failing in strength or serviceability, you can look at the ratios. There are combined ratios, there are actual ratios. So as per actual ratio, yes, as we can see for the slabs, the actual ratio, that is the demand capacity ratio, is going beyond 1. So it is failing, some of the members are failing for the actual. Then some are failing for the bending. Then some are failing for the shear. So these walls over here are failing for shear. And for flat slabs, usually we can go for the punching check. And then there is torsional ratio as well. So that's not checked because we have not used the option for the torsional design. But we do have the option to perform torsional design. Okay, so that's one thing. Then deflection check, well, that is satisfied. Stress ratio check, that is satisfied. Crack is not satisfied. So these plate beams are failing for the crack ratio. So crack width check is done by the program as per Eurocode, and they are failing as per the crack ratio. So this is how in detail and very easily we can understand the design result. That's about the overall view of the design. Now let's look into the reinforcements that the program has applied. So to check all that information, we can go to the RC section and we can look at the reinforcement details over here. So you can also do the modification of the reinforcements that have been applied. That is modify rebar option. You can see, you can visualize the reinforcement arrangement, and from here you can simply modify the covers, the number of reinforcements and their diameters. So that's how easily you can do the application and the modification of reinforcements. Okay, so that's about it. Then further, let's look into the tables. So we have the design results in the form of tables as well. So we can look at those information right over here. There is a total design result table. It tells about the status of our members. You can select the members from here, which of them are of more concern, likewise. You can also select over here, like whichever are not good, whichever are failing, you can just select them like this. So there is one wall which is failing. That's how you can get a design result output in the form of table, which is very easy. Then further you can get the results separately for the beams, for the columns, for the slabs, and so on. So again, you can select a beam and you can check the demand capacity ratios for each type of check. Alright, so that's about one thing. Now let's look at the design reports that will be generated. So we'll create a detailed design report for our members for, let's say, a beam, a slab, one column, and one shear wall. And let's click on OK. The Word file will be generated for the design result, the detailed design result for all the members that we have just selected. Okay, so there it is. We have got the result over here. This is for the beam that we had selected. As you can see, it shows the reference image, it shows the load combinations, and it also shows the calculations performed for that individual member. As you can see, there are references also given for the clauses that have been referred to. As you can see, it's quite a high quality report generated by the program, which you can probably use directly for your reports. You can see there is check for negative moment, positive moment, and shear check is also there. It checks for each part of the beam. It checks at the center and at the two ends, and you get the information about each section in this report. So a quite detailed type of report is generated. In other programs, you get a generalized report and then it gives you a summary of the result that has been obtained for that particular member. But in nGen, you can get a generalized, not a generalized, but a detailed report for that individual member that you select. So that was about the beam. I'll skip towards the column. Yeah, this is the result for the column. We can see here a PM interaction curve is also included for the column design. It performs the checks, the bending checks, the shear checks. It performs the serviceability checks like the stress check. Creep, linear creeps, or long-term checks are also available in the software. Then this is the design result for the wall. Effective length factors are automatically calculated by the program. The reinforcement arrangement is shown and you can get PM interaction curves for the wall as well. It also looks for the slenderness check, and as you can see, all the formulae have been provided to us along with the references. That's about the report generated by the program for the design. Now let's go ahead to the Report and Drawing tab and look at the report generator in the software. So we have got a report generator, it's called as a report maker. This is the report maker in the software. It shows us all the information about whatever is there in the model file. So all we have to do is simply double click to put it into a report board, which is the location of what all you want to include from the model. And once you create this report board, you can actually use it for several projects. So once you create your own report, let's say a procedure, then you don't need to go through this again and again. By just creating one template of your report board, you can generate your future reports by simply clicking on a Generate tab. So let me show you about what all things we can see over here. So we have our project information, what design codes we are using, what are the material properties that we are using, the reinforcing bars. Then we'll provide information about the model. So analysis model, we can show what we have used and the load combinations that are used. Then what are the lateral loads applied, so you can actually show the wind load story profile, seismic load story profile by story. Then you can provide over here the loadings that have been applied. So we have got a loading table that gives you information about everything. Then how are the supports applied, any links, diaphragms, everything that you actually need to provide into your report is available. Then further in the design part, you can specify the total result, or you can specify about each type of result like slab, beam, column, wall separately, or foundation as well. Then if you have performed the eigenvalue analysis and response spectrum loads, then you can apply the eigenvalue results as well. Now once you select all this information, all you have to do is click on Generate. As you can see, the program has now generated the information as per our model. Now this is a template that we have got. We can edit the view angles as well, that's not a problem. Okay, now let us say we have done some modification in our model file. So I'll go back to the model and I will, let's say, remove this column right over here. Press delete. Oh, I'll go to the pre-processing mode first. Press delete by selecting this column. Yeah, delete it, yes, and rerun the analysis and design. So a particular member is deleted, or maybe you have added some loads, you have changed the boundary condition, the shape of your entire structure is different, it's modified. Some modification, smallest or biggest modification that you have made in the model can be done, and after that whenever you go for creating your report maker, then let's see what happens. So our design is also being generated, analysis and design both. Of course our information will modify for everything that we have included over here. The design result will be varying, we will have different results for. Okay, basically right now we will see over here after the design is completed what happens. Now we will check for the updates and then we'll click on update data. So you can see over here now, after I click on generate, the program is going to automatically generate the entire project report as per our new model file. So there you go. Our column has vanished from here. I'll make a larger view so you can see it more clearly. So this column is gone, and these similar modifications will be made everywhere. So you can get the information. You can see over here this is also modified, analyzed model. You get the information about the story forces for as per the seismic loads and the wind loads, and finally this is the output result for the design. You can also include your project report, your detailed calculation reports over here. Now once you're done with creating this report, you can export this report into a Word file. So I'll just save this Word file at a certain location, and a Microsoft Word file will be generated. So once you're ready with the template, create your project report and then export it to the Word file, which can be further finally provided as an outcome of MIDAS engine. That's the Word file which will be generated by the program. Right, since the time is a little less, I will go back to MIDAS engine and show you the more important outputs, that is the drawing. So we have got drawings that can be generated out of the design that is done in the software. MIDAS drawing is a software solution that you can get along with MIDAS engine. It is an AutoCAD kind of tool. It's a CAD software basically. So if you want, you can use it for your CAD purposes as well. This is the software. It's a CAD tool itself, and as it is linked with MIDAS engine, you can generate the information. Now there are settings as well available for structural drawings and rebar arrangements. So these are as per the standard that you have selected for performing the design. So as per European standard as well, we have the rebar arrangements automatically done, as we have for British standards also. So few of you who are using British standards, you can still go for MIDAS engine and MIDAS drawing. So let's look at the structural plans that the program can generate. So I'll click on OK over here, and the program is firstly going to figure out what all drawings that it is supposed to create. It will take the information from MIDAS engine and generate all the drawings that it can provide as an output. So this is how it looks like at the beginning, and at the beginning only you need to wait for some time. Okay, till the drawings are getting generated, let me look at certain questions that we have over here. Alright, so there is a question about slanting columns. Yes, in case you have got slanting columns, you can model them in MIDAS engine software solution. You can actually just click on 2 points to create the members. That's CAD type of tool that we also have in the software solution. Okay, so let me go to the pre-processing mode and show you how you can do for an inclined column or inclined member. Any member, like you can have beams, inclined beams, you can have inclined columns, braces, and so on. So when it comes to columns, you can simply click at one point and you can click at another point, and as you can see over here, we can, this has snapped on to some other location. Let me reiterate. Okay, so it totally depends on where you are snapping. Okay, so I have snapped onto the center of this beam. Alright, so this is like an inclined column that is generated. It depends on the member that you have selected. So if this is a column member, it is going to be performing the design as per column for the columns itself. Alright, so that's about the inclined columns. Next, let's look at some more answers. How do we... Okay, masonry walls, load-bearing masonry walls. Well, yeah, you can include load-bearing masonry walls over here if you want to perform a linear elastic analysis of those masonry walls. So what you can do is you can actually model your plate elements over here, or you can also model the wall as plate elements, but I would recommend the plate elements over here, and just create the walls in this way. Just by 4 points you can create the plate elements. You can create by more points as well, not necessarily 4 points only. The program automatically does the meshing for you, so you don't need to actually take care of what is the shape of your member. So yeah, no need to discretize manually. Automatic meshing is done. Anyway, so you have your masonry wall in this way over here, on which you can apply further loadings. So if you don't have these columns, now this beam is resting completely on this wall. So you can apply the boundary conditions at the bottom and you can check the results. So I would like to just take you through this. Let's say we have got the supports over here as fixed ones, and then we go ahead to perform the analysis. Let me also check if this is included in our stories. So we have story information over here, and on the 1F level we have different members. Yeah, so we have our plate included, and it's 150. Let me just make it as 300 so that it can take a little bit and have some stiffness. So that's our plate. Let's perform the analysis. Okay, another question is about the footings and the foundations. So yeah, foundations also can be applied over here at the bottom in the similar way as I have created the masonry wall. So instead of creating plates in the vertical fashion, you can create the plates at the bottom. In MIDAS nGen, we have a special foundation type of member, so that you can get the design performed for a foundation design performed for your matte foundations, isolated footings, or your strip footings, or your combined footings. So all types of footings are possible in MIDAS nGen software solution. Yeah, so let's look at just the displacement result for now to see how this works. So as you can see, it is completely connected to the beams, and it has deformed along with the structure. So that's how you can get the load bearing walls also generated in MIDAS nGen software solution. Okay, let's look at the drawings. Those are generated now. These are the structural drawings which are generated by the program. At the bottom of the window, you can see this actually tells you how much time it's going to take, how much percentage it has taken to generate the drawing. So just wait for some time and we will get our structural drawings with us. Okay, there we are. So here's our structural drawing generated. This is for the ground floor or the foundation level, wherein we can get the grid lines, we can get the group names of our walls, also of our columns. We can get a list of columns and their sizes. Then we can get over here in the next page, this is how we can get the floor information. It talks about the slabs as well, beams and columns. It talks about the walls. It shows the openings. Let's look at the opening location of the slab. So this is where the opening is, and this is where we had a drop slab. So it has given a separate hat for showing that this is at another level. So that's something that the drawings can intuitively give us. Now let's look at the reinforcement arrangement for the beams and the columns. So I'll start with the beams right now. I've taken a roof beam for an example, and as you can see over here, the program has given a detailed reinforcement arrangement. At the top there are top reinforcement information, the length is there, the diameter is there, the numbers are there, and it has shown us the key plan where this beam is located for us to easily understand. It has given us a sectional view as well at I end, middle and the J end, and also the information about our ties. There are development lengths, splice lengths, which can be edited by us as well. And we have the bar bending schedule also. So we get the rebar shape, we get the lengths of each rebars and their size, their quantity, the total lengths, and for the ties as well, we get the total weight as well of the rebars. So that's about the beams. Similarly, we can get for the columns and also for the walls. So let me show you each one by one. So similar to wall beams, we can get over here the reinforcement arrangement of columns. That's about the reinforcements, longitudinal reinforcements, sectional view, and also the ties. The location of our column in concern, and the bar bending schedule. We can also get the rebar arrangements for the walls. Okay, so this is the wall in concern and these are the sectional views. And these are the longitudinal reinforcements. So horizontal reinforcements and vertical reinforcement information is provided. We can get such drawings as well wherever the reinforcement arrangement is required. So as you can see, the reinforcement arrangement is reducing, of course, as we go up, as the reinforcement requirement reduces. We can also get the bar bending schedule for the wall. So this is about the structural drawings. You can also get the information about the slabs. So we can get the list of slabs as well. So this is for all the slabs at all the floor levels. You can get typical drawings over here and you can specify the type of the slab rebar arrangements. So this is what the program has given by default as a slab reinforcements. These have been checked as per the standard, and of course after checking we are going to generate all our drawing outputs. This can be saved into a .dwg file. It can be exported into DWG file and you can use it into AutoCAD or some other CAD software solution which you are currently using. Also, the software is capable of producing bill of material in the form of Excel sheet. So let me generate the Excel file format of bill of materials. Alright, let me look at some more questions that are being that are asked over here. Yes, there is a question about staircase. Yes, we can include the concrete or steel staircase over here. It totally depends on how we are modeling it. I mean, we can model the inclined plate elements, we can model the spiral plate elements as well that can be used for steel or RC type of staircase like ramps. Design groups, well, design groups are going to be, that was another question, what are design groups? So design groups are actually automatically created by the program depending on the section shape and the reinforcement arrangements. So if the groups are created before the design, they are based on the length and the shape of the member, and if they are done afterwards, then you can get it as per the reinforcement arrangement as well. Alright, so we have got our bill of materials generated, so you can get the result for the steel, you can get it for the members of RC. You can get the concrete volume in meter cube, rebars in ton, and form work as well. So form work information is also given for each member. that's formwork area. We can get the result for each group, and I mean this is like totally dependent on how you want the output. If you want it separate, not for like separate groups, but all together, then you can actually ask the program to do likewise. There are several options of creating these bill of materials, but this is how in detail we can get the bill of material generated. Okay, so that is about MIDAS nGen. Now let me get back to the presentation to talk about the high quality outputs. So as you can see, we could get the reports generated in the Word file by simply selecting it. Detailed report, also we saw several reports can be generated for several members at once. And they have got codal provisions with subclause numbers as well. Then further we can use report maker to generate the information about our model file, our project. And this is going to show the same thing. So let's move ahead. Drawings. So drawings can also be generated by the program. We just saw how easily the structural plans and the reinforcement arrangements were easily done by the drawing software. Alright, so let me tell you about the support service that is offered by MIDAS. If you want to use MIDAS software solutions, you can start it immediately, as we have got video tutorials available on our website, and you can ask us about any problems that you face while you're getting into the software. So like you can see, you can get videos right from how to start with the software solution. Okay, so let me conclude my webinar today that MIDAS nGen is available for us all because of its integration that can integrate the shape model and with the analysis model. There are automated functions that can help you to easily create the model, and there is auto mesh as well, so you don't need to worry about meshing your slab. Then further there is optimization that can be done by the program. Then further high quality outputs like reports and drawings can be generated by MIDAS nGen and MIDAS Drawing. So that is the end of our session. If you have got any questions, please let me know. Please write down at the questions box. There are several more questions actually available over here, but as there is a time constraint, I think I will be answering to all of your questions by email. But I would yeah, I think I did not mention one thing about the meshing part. So let me just show you about how the meshing is generated by the program. So this is analyzed model. Let's look at the mesh edge. So whichever elements that were plate type of slabs, those have got meshed. So this is how the automatic mesh looks like. You can see over here as well the automatic mesh generated. So the nodal connectivity is always maintained by the program. As you can see, this is completely maintained by the program over here, the nodal connectivity. So you need not worry about the connections at all. Those errors can be neglected. Basically, they won't occur. But again, this is about the inputs that we provide. So if we provide the proper inputs, we'll get the proper outputs. Okay, so that is it that I wanted to show. Thank you very much everyone for attending our session. This